Hi, I'm Teacher Michael and welcome to Science 9, 4th quarter, week 3 and 4. Momentum, impulse, and conservation of momentum. Momentum and impulse. To introduce our lesson, let us take a look and observe the different figures. Figure 1. A truck and a car hitting a wall. If the two vehicles in Figure 1 suddenly lose their brakes and crash against the brick wall, which do you think would be more damaging? Is it the car or the truck? What factor would affect the impact of collision if their velocities are the same? Figure 2. Identical cars of different velocities. In Figure 2, Car A or the car number 7 is traveling at 80 km per hour while car B is traveling or the car number 4 is traveling at 30 km per hour. Which of the two cars would be more difficult to stop? Which of the two cars has more momentum? Figure 3. Hitting a baseball. The baseball player in Figure 3 exerts a great amount of force in hitting the baseball. What is or are the effect or effects of this force on the baseball? Why does the man have to do a follow-through after hitting the baseball? A body's momentum is its tendency to resist any change in states of motion or rest. Ito yung pagpigil sa isang gumagalaw na bagay o yung paggalaw sa isang nakatigil na bagay. It is also known as inertia in motion. Momentum depends on two factors, the mass and velocity. So to get the momentum of a certain object, we have to multiply its mass to its velocity. Therefore, P or momentum is equal to m mass times v or the velocity. For bodies moving at the same velocity, the more massive body has greater inertia in motion, therefore has greater momentum. If a certain body, for example two vehicles, the bicycle and the car, have the same velocity or they have the same bilis o yung parehas ang kanilang bilis, but the other one has a smaller mass and the other vehicle has larger mass. The larger mass has the larger momentum because it has greater inertia in motion. Thus, in Figure 1, if both the truck and the car are moving at the same velocity and lose their brakes, the truck would cause more damage on the wall by virtue of its mass. In this situation, in this Figure 1, the truck has more damage than the car because the truck is more massive or it has more mass. Two bodies of the same mass but different velocity will also have different momenta, like in Figure 2. In Figure 2, cars A and B have the same mass, but since car A has greater velocity, it has greater momentum, making it more difficult to stop than a car. So in this situation, they are identical but they are in different velocity, magkaiba naman ng bilis. The car number 7 has greater velocity tends to have a greater momentum because siya yung mas mabilis. So, to have a greater momentum, for an object to have a greater momentum, it should have a greater mass and it is also should have a greater velocity. In physics, an external force acting on an object over a specific time leads to a change in the momentum of the object. Ang momentum ng isang bagay ay pwedeng magbago kapag merong external force na mag-act sa kanya in specific time. A special name is given to the product of the force applied and the time interval during which it acts. So that is what we call impulse. If there's a change in momentum because of the application of force in a certain time of contact, there's a impulse, or there's what we call an impulse. An impulse is the product of the force applied and the time interval. As shown in figure 3, the baseball player exerts force to change the baseball's momentum by hitting it with a bat. So the baseball momentum changes because it was hit by a bat. Because of the application of the force from the bat to the baseball momentum changes. He does a follow-through to increase his time of contact with the baseball and change its momentum further. So, since the baseball's momentum changes, there's already an impulse. The baseball's momentum changes because of the application of force in a certain time. For activity number 1, read and analyze each statement carefully. Complete each statement by choosing the correct word inside the parentheses. So what we're going to do is to choose the right word inside the parentheses. Number 1, a dump truck that is not moving. Again, a dump truck that is not moving has greater or lesser momentum than a toy car that is moving. So again, to have a greater momentum, the object should have a greater velocity and greater mass. Number 2, if a moving car moves twice as much or twice as fast, its momentum would be the same or twice as much. Number 3, two cars, one twice as heavy as the other, moves down a hill at the same time. The heavier or the lighter car would have greater momentum. So which of the car would have a greater momentum? Is it the heavier one or the lighter one? Two boys with identical masses are running towards the finish line in a race. The one with greater or lesser velocity has more momentum. Which will has a more momentum? Is it the boy that has greater velocity, or is it the boy with lesser velocity? Number 5, a soccer player needs to apply large or small amount of force to change the ball's momentum. The momentum of a body is the product of the mass and its velocity, as in the equation P is equal to mv. Momentum is equal to mass times velocity. Force is needed to change the momentum of a body. This force multiplied by time of contact is known as impulse. So I is equal to Ft, or force times the value of time. There's an impulse if there's a change in the momentum, or the change in momentum results in impulse because the momentum changes if there's an application of force for a certain time. So therefore, impulse Ft is equal to change in momentum, or m delta v. So therefore, change in momentum is equal to impulse. There's a change in the momentum if there's an application of force in a certain time, or what we call impulse. Bodies change their momentum through collisions, which may be elastic or inelastic. The SI unit for momentum and impulse is Newton second, or kilogram meter per second. Sample problem. Number 1. What is the momentum of 22 kg grocery cart which travels at 1.2 meter per second? Given. Mass is 22 kilograms, that's the mass of the grocery cart, and the velocity of the cart is 1.2 meter per second. We are looking for the value of P, or the momentum. To get the value of P, we have to use the formula P is equal to mv. So what we're going to do is to multiply the mass to its velocity. Substituting the value to the formula, 22 kilograms is the mass times the value of velocity, which is 1.2 meter per second. The answer is 26.4 kilogram meter per second. So the momentum of the grocery cart is 26.4 kilogram meter per second. Number 2. An offensive player passes a football of mass 0.42 kg with a velocity of 25.0 meter per second due south. If the player is in contact with the ball for 0.050 seconds, what is the magnitude of the average force he exerts? So in this problem, we will now relate impulse to momentum. So there's already a change in momentum because of the application of force from the bat to the ball. Given, mass of the ball is 0.42 kg, or mass of the football is 0.42 kg. The velocity of the football is 25.0 meter per second going south, and the time of contact is 0.050 second. We're looking for the value of force, so the amount of force exerts on the football. Solution. To get the value of force, we will use the formula Ft is equal to mv. So this is the impulse, which is Ft is equal to mv, which is the momentum. So this is the impulse momentum theorem. There's a change in momentum if there's an impulse. So to get the value Ft, we have to derive this formula, divide both sides by t. Then we will have this formula, F is equal to mv over t. Using this formula, we can now get the value of force, or F. Substituting the value to the formula, F is equal to 0.42 kg, that's the mass of the ball, times the velocity of the ball, which is 25.0 meter per second, divided by the time of contact, which is 0.050 seconds. Multiply it first, this one, then divide this, and divide the product of this to this. So the value will be 210 kg meter per second squared. So that is the applied force, or the amount of force exerted on the football. 210 kg meter per second squared, or 210 Newton. For your activity number 2, what you're going to do, given the following data, complete the table below. See the example in the first row of the table. So what you're going to do is to identify the momentum of each object with their given mass and velocity. Example, tennis ball. The tennis ball has a mass of 0.05 kg and a velocity of 10 meter per second. So to get the value of its mass, we have to multiply its mass to velocity. So momentum is equal to mass times velocity. The mass of the tennis ball is 0.05 kg times the velocity of the tennis ball is 10 meter per second. So 0.05 times 10 is equal to 0.5 kg meter per second. The momentum of the tennis ball is 0.5 kg meter per second. So what you're going to do is to identify the momentum of the bird, the basketball player, the bullet, baseball, and the frog with their given mass and their given velocity. Conservation of momentum. You have learned before that an external force is required to make an object accelerate. Similarly, if you want to change the momentum of an object, an external force is required. So para magkaroon ng change in momentum, there should be an external force. Pero kung walang change ng momentum, wala ring external force. Let's take this situation as an example. Two children on skateboards are initially at rest. So this is the two children. They are in a skateboard, initially at rest, nakatigil. They push each other so that eventually the boy moves to the right while the girl moves in the opposite direction away from each other. So they push each other, the boy will move to the right and the girl will move to the left. Newton's third law tells us that the force that the girl exerts on the boy and the force that makes the girl move in the other direction are equal of magnitude but opposite in direction. So the amount of force exerted by the girl to the boy is equal to the amount of force from the girl, amount of force by the girl, or the reason of the girl to go back or to move to the left. So meaning to say, yung amount ng force na in-exerted dun sa boy ay yung amount ng force na dahilan kung bakit siya pumunta sa left. Okay? So they have the same value but in different direction. The boy and the girl make up a system, a collection of the objects that affect one another. No net or unbalanced external force acts on the boy-girl system. Thus, the total momentum of the system does not change. There's no external force acted on that system. It is just the forces of the boy and the girl. Figure 1. In this example, the total momentum of the body of the boy-girl system before pushing is 0. Their momentum before pushing is 0. After pushing, the total momentum of the boy-girl system is still 0. Why? Because the momentum of the girl is of equal magnitude but opposite direction to the momentum of the boy. Because the momentum of the girl is just equal to the magnitude of the momentum of the boy, but in opposite direction. Note that the momentum of the boy alone is not the same before and after pushing, and the momentum of the girl alone is not the same before and after of pushing. So in this boy-girl system, their momentum is conserved because there's no change, there's no external force acting on it, and it's just the force of, from them. So then their momentum have the same value. They have different direction. So parehas ang value ng momentum pero opposite lang ang direction. So meaning to say, yung isa negative, yung isa positive, pero parehas ang value. Therefore, their momentum will come to 0. Zero momentum means the momentum is conserved. For activity number 3, balloon rocket, 5 points. Describe how a balloon rocket works and how conservation of momentum explains rocket motion. So what are the materials? Balloon, long shape, drinking straw, string, nylon if available, and tape. Procedure. Number 1. Stretch the string over 2 posts. You can use shears or iron stand as posts. Make sure that the string is taut. Number 2. Inflate the balloon. Twist the open end and temporarily secure it with a paper clip or tape. Number 3. Tape the straw to the balloon such that it is aligned with the balloon's opening. You can see this figure 3, the balloon rocket setup. So this is the setup of our experiment of balloon rocket. Number 4, draw a diagram showing the momentum vectors of your balloon rocket and the air. So after doing the experiment, you have to answer these following questions. Number 1, how these momenta compare. So what you're going to do is to compare the momentum of the rocket, the balloon, and the air that comes out. Number 2, how does the velocity of the air that is pushed out of the rocket compare to the velocity of the balloon rocket? In the previous activity, at the start, our system, which consists of the balloon and the air inside it, are stationary. So the total momentum of the system is 0. When we let the air inside the balloon out, we notice that the balloon moves. The force that causes the balloon to move comes from the air that is pushed out of it. So the reason why the balloon moves or moves forward is because the air that comes out. There is no external force involved, thus the momentum of the system is conserved and must remain zero. If the balloon has momentum in one direction, the air must have an equal and opposite momentum for the total momentum to maintain or to remain zero. So, the change in momentum in that system is zero. Total initial momentum is equal to total final momentum. So, the initial momentum before the balloon moves or released is zero. So, 0 is equal to the total final momentum, which is the momentum of the balloon plus the momentum of the air. P here is the momentum. Okay, so we're just going to the P balloon, or the momentum of the balloon will be transposed to the other side, so making this will become negative. So negative momentum of the balloon is equal to the momentum of the air. Let us expand the formula. Remember, momentum is equal to mass times velocity, so we're just going to expand this P to m times v. So momentum is equal to m times v, therefore negative mass times velocity of the balloon is equal to the momentum of the air, so mass times velocity of the air. Since the mass of the balloon is greater than the mass of the air, the velocity of the air must be greater in magnitude than the velocity of the balloon and must be opposite in direction. Since the mass of the balloon is greater, mas mabigat yung balloon, para maging equal yung momentum ng balloon at ng air, dapat yung air mas mabilis kaysa sa kanya kasi nga mas magaan lang siya. Sample problem. Two ice skaters stand together. They push up and travel directly away from each other. The boy has a velocity of 1.50 meter per second. If the boy has a mass of 75 kg and the girl has a mass of 50 kg, what is the girl's velocity after they push off? Consider the ice to be frictionless. So the given are: the velocity of the boy is 1.5 or 1.50 meter per second. The mass of the boy is 75 kg and the mass of the girl is 50 kg. So we are looking for the velocity of the girl or the girl. To get that, the formula is the momentum, the negative momentum of boy is equal to the momentum of the girl. So let us expand it. So P is equal to mv. So negative mv, the boy, or the mass velocity, negative mass velocity of the boy is equal to the mass velocity of the girl. So using that formula, we can now solve the value of velocity. The total initial momentum is equal to total final momentum. So 0, the total initial momentum before this situation or push off is 0, is equal to total final momentum, the momentum of the boy plus the momentum of the girl. So let us just transpose the momentum of the boy to the other side to make it negative. This one, ito lang po yun. Okay, it is just a formula. It is just show where this formula come from. So from here, then this one. Let us expand this formula. So we will get, again, momentum is equal to mass times velocity. So the negative mass velocity of the boy is equal to the mass velocity of the girl. Let us substitute the value to the formula so we can get what is the mass of the boy. That is 1.5 meter per second. I don't know. The mass of the boy is 75 kilogram. Sorry. Then the velocity of the boy is 1.50 meter per second. So negative siya, is equal to what's the mass of the girl, that is 50 kilogram, times its velocity. Ito yung hinahanap natin. So what we're going to do is to multiply this one first. We will get, so 75 kilogram times 1.50 meter per second. May negative dun sa labas, so negative 37.5 kilogram meter per second is equal to 50 kilogram v girl. So we're just we're looking for the velocity of the girl. So to get the velocity of the girl, we have to divide both sides by 50 kg para matira lang si velocity of the girl here. So divide both sides by 50 kg. Okay, so makakancel yung 50 dito. It is already 1, so 50 by 51. So let us cancel it out na. Yung kilogram din makakancel, and makakancel din si kilogram. So matitira yung meter per second. Okay, so negative 37.5 divided by 50, that's the velocity of the girl. So the value is negative 0.75 meter per second. The velocity of the girl is negative 0.75 meter per second. The girl moves with a velocity of 0.5 meter per second opposite to the direction of the boy. Since it is opposite, therefore it is negative. Okay, let's have the activity number 4. For activity number 4, problem solving 10 points. Solve the problem, show your solution. A candy-filled piñata is hung from a tree for Matthew's birthday. During an unsuccessful attempt to break the 4.4 kg piñata, Hayden cracks it with a 0.54 kg stick moving at 4.8 meter per second. The stick stops and the piñata undergoes a gentle swinging motion. Determine the swinging speed or velocity of the piñata immediately after being cracked by the stick. So the way we solve the sample problem is also the way we can solve this problem. So this is the momentum of the stick, or the negative momentum of the stick is equal to the momentum of the piñata, wherein the negative mass velocity of the stick is equal to the mass velocity of piñata. So the what are the given? The mass of the piñata is 4.4 kg. The mass of the stick is 0.54 kg. 0.54 kg, and the velocity of the stick is 4.8 meter per second. We are looking for the velocity of the piñata after it was hit by the stick. Okay, so just review again the sample problem for you to be able to answer this activity number 4. Elastic and inelastic collision. A collision is an encounter between two objects resulting in exchange of impulse and momentum. Because the time of impact are usually small, the impulse provided by external forces like friction during this time is negligible. If we take the colliding bodies as one system, the momentum of the system is therefore approximately conserved. The total momentum of the system before the collision is equal to the total momentum of the system after the collision. So this is total momentum before collision and total momentum after the collision. It is just equal, or whatever the value of the total momentum before the collision is equal to the total momentum after the collision. So yung pagbabanggaan. Collisions are categorized according to whether the total kinetic energy of the system changes. Kinetic energy may be lost during collisions when it is converted to heat or other forms like binding energy, sound, light if there's a spark, etc. And 2, it is spent in producing deformation or damage, such as when two cars collide. The two types of collisions are, we have elastic collision and inelastic collision. So what are those? Elastic collision, one in which the total kinetic energy of the system does not change, and colliding object bounce off after collision. So it's just before collision, then once they collide, they just bounce back. Okay. Elastic collision, yung top, moving object collides with stationary object. Sa middle, two moving objects collide head-on. Then, this one, after collision, two objects moving in the same direction. So, they just bounce off. Okay, nag-bounce off lang sila after they collide. So that is what we call elastic collision, in which the total kinetic energy of the system does not change. So there's no change in the total kinetic energy. While in inelastic collision, one in which the total kinetic energy of the system changes. Dito may pagbabago ng kinetic energy. Some of the kinetic energy are converted to other form of energy. Objects that stick together after collision is said to be perfectly inelastic. So, in elastic collision, two objects collide, stick together, move as one. So, once they collide, they stick together and move as one. That's what we call perfectly inelastic. So, some of the energy is converted to other form of energy. For your short quiz, choose the letter of the correct number. For questions number 1 and 2, refer to the data below. We have two vehicles here, the jeepney and motorcycle. The mass of the jeepney is 2,000. It has velocity of 10. And the mass of the motorcycle is 300. And it has a velocity of 20 meters per second. In the table above, what is the momentum of the jeepney? So to get the value of momentum, we have to multiply the mass times velocity. So again, in the table above, what is the momentum of the jeepney? Letter A, 6,000 kg meter per second. Letter B, 40,000 kg meter per second. Letter C, 20,000 kg meter per second. And letter D, 3,000 kg meter per second. Number 2, which has greater momentum, the jeepney or the motorcycle? Letter A, jeepney. Letter B, motorcycle. Letter C, both have the same momentum. And letter D, cannot be determined. Number 3, two identical cars are traveling along EDSA. Which of the two cars would have a greater momentum? Letter A, a slower car. Letter B, the faster car. Letter C, both have the same momentum. Letter D, cannot be easily determined. Number 4, a bus and a car are traveling along EDSA having the same velocity. Which of the two vehicles would have a greater momentum? Letter A, the bus. Letter B, the car. Letter C, both have the same momentum. Letter D, cannot be easily determined. Number 5, a 25 kg girl is riding a 5 kg bike with a velocity of 5 meters per second east. What is the total momentum of a girl and a bike together? Letter A, 100 kg meter per second. Letter B, 125 kg meter per second. Letter C, 150 kg meter per second. Letter D, 200 kg meter per second. What you're going to do is you multiply 25 times 5 plus 5 times 5. So to get the value, the total momentum of the girl and the bike. Number 6. Which is necessary condition for the total momentum of system to be conserved? Letter A, kinetic energy must not change. Letter B, no external force is present. Letter C, an object must be at rest. Letter D, only the force of gravity acts on the system. Number 7 to 8. For number 7 to 8, two 0.5 kg balls approach each other with the same speed of 1.0 meter per second. Number 7. What is the total momentum of the system before collision? Letter A, 0. B, 0.50 kg meter per second. Letter C, 1.0 kg meter per second. Letter D, negative 1.0 kg meter per second. Number 8. If there is no external force acting on the system, what the total momentum of the system after collision? Letter A, 0. B, 0.50 kg meter per second. Letter C, 1.0 kg meter per second. Letter D, negative 1.0 kg meter per second. Number 9. Two billiard balls approach each other at equal speed. If they collide in a perfectly elastic collision, what would be their velocities after collision? Letter A, 0. B, same in magnitude and direction. Letter C, same in magnitude but opposite in direction. Letter D, different in magnitude and opposite in direction. Number 10. A 50-kilogram astronaut ejects 100 grams of gas from his propulsion pistol at a velocity of 50 meters per second. What is his resulting velocity? So to get this, the value of this one, it is just like the activity number 4. Letter A, negative 0.10 meter per second. Letter B, negative 0.50 meter per second. Letter C, 0 meter per second. Letter D, negative 100 meter per second. Reminder, what we're going to do are answer activity 1, 2, 3, 4, and short quiz of this week 3 and week 4. The total points is 40 points. Good luck! Thank you for watching and listening. If you have questions, don't hesitate to chat me. Have a nice day.